me see. Yeah, we are live sending data. Mm, if I can go into, hey guys, if any of you able to hear us, let us know if we are live or not. We are still trying out. We are figuring out. Let me go on an event and see if we are able to live there.
We are live on YouTube. Looks like maybe,
Yeah.
or maybe not.
Anything
So
show
if
up on
I,
LinkedIn yet?
It says waiting for.
yeah,
Maybe
I
there.
don't know why it's LinkedIn is always the same thing, like waiting for this one. However, YouTube is live. So,
Yeah, LinkedIn is slow. LinkedIn tends to be behind.
oh really?
Yeah, I've done a bunch of these in the past too, and it took a little while for LinkedIn to kind of catch up.
Okay, but let
They,
me
they
share.
got to be using Java. It needs to warm up.
Warm up the heap.
Yes.
Um, we are live on YouTube. Okay, YouTube. Cool. I can share this, and hey guys, if you can post that, if you can share that too, that would be nice. How I can do that? Pre-live, it's showing pre-live in a. We are live on data. We are live on YouTube. Sorry. Perfect. I can CC you both.
Yeah, I just posted on LinkedIn as well, but LinkedIn is a little slow.
Yes, showing streaming, but I don't know why. It's not. Uh, anyways, at least we have one place to look to, uh, to see.
And this
So
is
I
being
will.
recorded as well, right? So it can be
Yeah,
shared.
exactly,
All right,
exactly.
awesome.
So I think we can get started, right?
Let's do it.
So hello
Let's do that.
everyone. Good morning, good afternoon, good evening, good night. I don't know which part of the globe you're watching from. So happy to I'd love to welcome you in my next podcast, Data Lake 2.0 slash Lake Lake House Architecture slash Modern Day Architecture slash Cloud AI. So I would like to. This is Navnit. I'm a host of this podcast, and don't forget to join my YouTube channel. I'm uh, looking for a subscriber for my YouTube channel, so don't forget to join it. Okay. Yeah. So let's me introduce my guest, Gagan and Roy. I've been knowing them from ages now, so I will let them introduce themselves. Roy, over to you.
Thanks. First of all, Navneet, thank you for having me. I really appreciate it. And Gagan is great connecting with you again. Roy Hassan, I'm currently the VP of product at a company called Absolver. We're an iceberg lake management platform. Previously, I worked with these fine gentlemen here at AWS. I was a product manager for a few of the analytics services there, like AWS Glue and Lake Formation, Amazon Athena. Worked on many of those. So 6 years there, and then almost 3 years at Absolver, and been in this industry for quite some time. But yeah, looking forward to this conversation.
Perfect. Again, over to you.
Sure. Thank you for having me, Navneet. It's a pleasure to working with you and chatting with you. And likewise, Roy, I've worked with both of you. It's an excellent opportunity to collaborate and discuss some of the industry trends here. Hello, everyone. My name is Gagan Brahmi, and I am the Senior Analytics Specialist Solutions Architect covering the North American customers at AWS. I am based out of the San Francisco Bay Area. I've been doing data for, I don't know, 10 years now, especially the big data, and been with AWS helping out a number of our enterprise customers to build their solid data strategy. Been with AWS for a little over 5 years. I am really excited to discuss some of the newer trends that we are seeing today in the industry.
Perfect. So before we go deep on this discussion, I want to put a disclaimer. Actually, it's going on the screen too. So all the opinion expressed here are solely ours and has nothing to do with our employer. It goes through with Gagan as well as Roy. So again, we wanted to have open discussions, irrespective of our employer, and have a further discussion like, okay, how the trend is going around the data industry. So let's, and again, this podcast are divided into multiple segments. So we are moving towards our first segment. The first segment, we call it industry shift to a transactional data lake, right? So if you're not aware of a transactional data lake, as terms it says, you're able to perform transactions on a data lake. But I will let have a more conversation with my guest here. So Roy, let's start with the big picture here, right? The shift from the transactional data lake to transactional data lake is making waves in this industry. And so what do you think, like, primary driver behind this shift, and how the organization going to impact on with the shift?
Yeah, so I think it's a good question. I'm sure Gagan has a lot of thoughts on this as well. I think generally what I've seen personally, and kind of the feedback I've heard from companies that I spoke to, um, so like if you look at the past, right, you got the warehouses, place to put stuff, you can easily update records. Kind of feels like a database, but it's a big data space, right? I can put a lot of data in there. And then we kind of transitioned into a data lake model with Hadoop and that ecosystem, data stored on top of HDFS, stored on top of object store. And that really opened up the world to truly a lot of data, right? So like once you move to the object store, that's really when you unlocked a ton of power and flexibility in both bringing your own compute, whatever you want it to be, whether it's, at that point, Hive and Tez and, Pig and all those things, and eventually Spark and Flink and Trino, et cetera, really open up the options for compute, but then give you a lot of flexibility with your data, where you store it, how much you keep, et cetera. And that sort of ushered the era of the data lake. The problem with that is that people sort of looked at the data lake and said, it's replacing the warehouse. Right? Everything I did in a warehouse that was really expensive, I can now do it in a much higher scale and a much lower cost in a data lake. But there was one big thing that wasn't solved by the data lake, is data management. Right? Now, to manage data, I'm sure both of you guys here had no problem doing it because you can write the code, you can manage it. Large majority of the users couldn't. Right? We all spend a significant amount of time with customers at AWS, actually showing them like, this is how you write the code to update your data in an object store. It's immutable. You got to delete a file, then you got to upload a new file. You can't just go in there and replace a row. But wait, I have hundreds of terabytes of data. How do I do this at scale? That was really hard. So granted, we made it very flexible and cost effective, but the problem of data management was still really, really hard to do. And then we kind of saw the Snowflake world, Snowflake come out and saying, oh, we're faster, we're better, blah, blah, blah. People sort of shifted over to Snowflake again, or to that modern warehouse again, because it was easy and fast. Now we're shifting back towards the LakeHouse, Data Lake 2.0, Transactional Data Lake, call it whatever you want. The reason that shift is happening is because there's a new set of technologies, these open table formats, that are here to solve the data management piece that we didn't solve in the first iteration of the data lake, or even the second, right? So that's kind of coming in with Iceberg and Hoodie and Delta and Pymon and all these other ones that are saying, hey, we know how to store data and how to manage data in S3 and object stores. You as a user don't need to worry about it. You don't need to know how to update or delete a row. We got it covered. So you just insert the data, we'll figure out the rest. And I think that sort of says, hey, all the benefits of that they like promised you a few years ago, now they're reality, because now anybody can actually use it, not just the super smart technical people who know how to write code and how to manage that code. So for me, that's kind of the shift why we're seeing a lot of interest in these Lakehouse formats, because it unlocks the power of flexibility and cost savings and minimal vendor lock-in, but it eliminates a lot of the complexities that came along with data lakes.
Okay, that's really cool explanation. So, follow-up question to you, Gagan. Can you share an example, like which industry you think is moving fast in this direction, where they wanted to have a data lake 2.0, transactional data lake, or lakehouse architecture, with your expertise working with so many customers?
I would call out a couple of industries. The first is obviously the companies who are born in cloud, right? the digital native business. They're born in cloud. They know they are going to be working with data. They are going to be data driven, and they collect a lot of data. And that those are the companies where they want to have a solid foundation or a platform that they can rely on to start innovating and making sure that they are giving more and more better products to the customers. On the similar lines, the other industries that I cover and I work very closely is the ISV segment. The ISV customers are the ones that they rely on data to make better products, to make that experience, like all the companies that we talk about, right? Snowflake and other ISV customers that build on top of different clouds, but they still need a relevant data. And they can't really afford to store that data in a data warehouse because, believe it or not, sometimes data warehouse, after a period of time, it becomes really crazy expensive. And removing that licensing requirements and the attached storage and compute, it's a shift that a lot of customers and industries benefit when they store it in a central repository. But again, as Roy was pointing out, the learning curve was significantly higher in the previous iterations of Data Lake. But Data Lake 2.0, or Transactional Data Lake, or modern data platform that we call it, we now have, if not exact same, but familiar or similar capabilities where you can now go ahead and make changes, updates, deletes, modify the data without really rereading the entire data, which was the biggest drawback in the previous iterations for the data lake. So yeah, I would like to call out that industries which are going to be big beneficiaries. And one industry I should also call out is the FSI, the financial services. They are also the ones who are always bleeding edge. They want the best of technologies. Securities is an important thing for all the industries, but when it comes to FSI, it becomes more so critical. And they want to use what is the latest and greatest available in the market, and that what can help them to give a more innovative experience and product experience to their end customers. So I would say FSI, ISVs, and DNBs.
Yeah.
Again, those are very, very kind of, they are kind of in smart people. They have really good engineering teams, but there are a bunch of customers, they still on like more like a traditional way of doing the data management. And now we already been in era where we have talked around data lake, data warehouse, data lake, data warehouse. Now we be like, in the transactional data lake world now. And when we talk around the transactional data lake world itself, we are having multiple options. We are having the Delta Lake options. We are having the Hoodie options. We are having an Iceberg option. So, Roy, to your to your opinion, right? Let's say I'm an organization. I'm looking to get started. And when I say like I'm not organization, I'm not talking about super organization with a super strong engineering team. If I have to get started, and when I hear all this 3 4 different kind of options available within the market, I will get like, okay, terrified.
Yeah.
Hey, where I should be getting started, whether I should be keep doing my data warehousing, or I should be moving towards like, this transactional data lake. So
Yeah.
what's your advice? Like, where should someone starting their journey?
Yeah, it's a great question. I think anybody you ask will give you a different question, a different answer. My perspective is this: you got to think about what is the most critical business decision that you need to make with the data. Gagan was talking about earlier about why or that transactional data lakes are really adopted by customers who are data driven, right? Or really making products based on data. Data is kind of the core asset, right? As opposed to like a secondary thing that you just use for BI. So if you're that company, right, you are then saying that data is gold. Data is the thing, the most important part about my business. So if that's the case, from my perspective, then you need to think about openness and minimal lock-in in the tooling that you're choosing. Right? I spoke to a company this morning, and the guy really highlighted that. He said, like, we're using Databricks, we're using Snowflake, we're using all these vendors, but this data is gold. Like this is if I lose this data, I'm screwed. Or if I have to migrate this to something else, it's going to cost me tens of millions of dollars. Like this is the most important thing. So from that perspective, you need to come at it and think, okay, what is the most which table format is kind of the most open, the one that has the most balanced ecosystem of contributors, has the most trajectory or force behind it to drive it forward. As much as people will tell you Delta Lake with Databricks is open and all that kind of stuff, yes, but it's heavy influence by Databricks. If tomorrow they decide, like, you know what, we're not going to do this anymore, or tomorrow we're going to say, like, listen, these features, we're going to bring it inside into Databricks and you have to pay for us, nothing is going to really stop them, right? They've shown this by developing a lot of features first for the Databricks runtime and then opening them up to the community, right? Or the community basically have to chase after them to say, hey, how did you do this? We want to build the same thing. I don't think that's an ecosystem you want to be a part of, right? Now, if you're a Databricks customer and you use them all the time, by all means, right? You live in that space, you're happy with it, good for you, right? I think Iceberg is much more open. There's a much broader set of contributors and a big community around it. You're seeing the adoption with AWS across the board, Snowflake, Databricks, as much as they're talking about Delta, if you're using Spark in Databricks, it has Iceberg support 100% and it works, right? Salesforce, BigQuery, Azure, not yet, but they're talking about it. So I think it's a big enough ecosystem to say, like, look, if I really want something that's not super tied to one vendor, Iceberg is probably the one I'm going to choose. Now, I would say there's Hoodie as well, there's Paimon, but for me, they're more specific to unique use cases. Like Hoodie is very performance optimized for more streaming things. It's harder to use. Doesn't have as much adoption across the board with query engines and execution engines. Paimon is even the same, right? Really only works with Flink, a little query support from other vendors like Trino, but for the most part, today it's not really usable. So it really leaves you with Iceberg and Delta. In my opinion, Iceberg is, and I'm biased, of course, because at Upsolver, we sort of picked Iceberg as the horse to ride, but I see it as the biggest ecosystem. I see it as the biggest adoption across the board, and it's going to continue like that.
Yeah, maybe I can ask a little controversial question here.
Sure.
So now with the acquisition of Tableau by the Databricks and making the Unity data catalog open source,
Yeah.
what's your reading here?
Yeah. So again, I mean, I talked a lot about this. I have videos, I have stuff on LinkedIn that you can hear. One thing I want to make sure is people really understand is that when Databricks acquired Tabular, they didn't necessarily buy a product. They didn't buy technology. They bought PMC members. They bought people who sit on the Iceberg PMC board, and they bought contributors. In the open source world, those things are gold. Like if you're a PMC member in one project, you can be a PMC member in other projects. It's easier, right? If you're a contributor, like an actual code contributor in a project, it's easier for you to become contributor somewhere else. And that is huge, right? For companies, right? Which is also why Snowflake wanted Tabular for those people. They're not bringing any technologies. Spark already has full support for Iceberg. Unity Catalog, I guarantee you, if Databricks puts some people on it, in less than a week, they got full Iceberg Catalog support in Unity. So they didn't really buy them for technology or product or customers. Tabula didn't have any customers. They had some people playing around.
I'm sure this clip gonna go viral, Roy.
I hope so. I hope people need to understand this. But honestly, I think, look, the Tabular folks are fantastic people. They've done a fantastic work in the community. What is Databricks going to do with this? I don't know. Honestly,
Fair
like
enough,
I
fair enough.
feel like it's kind of like flexing your muscles a little bit.
Okay,
You know,
let's move to our next segment. So where we're going to learn around. Hey, we have been hearing so really good about all this good stuff about transactional data lake. Have you, if you're following enough, we had the similar discussion around the data mesh architecture, right? So do you Gagan, if we talk around like key challenges. So let's say if someone is looking to migrate to this transactional data lake world, what will be your, like, maybe if you have to highlight three top challenges they should aware of even before they make a decision, hey, I have to go and move to platform.
I think the biggest thing that an organization, before they even look about adopting a data mesh or moving towards that architecture, is to first have a strategy, right? Data mesh, or I will also put another term, data fabric, right? There are two terms that I work really closely today. They solve the problem of access. They solve the problem that make the data accessible to multiple users. Now, if you don't have a sound strategy and you go all guns blazing out like, hey, I want to build a data mesh and I will bring all the different technologies, that will not work. Understanding and assessing your current landscape is an important aspect. You assess your current landscape, see what are the things which are important for you. Your data landscape, so things like, are you using a data warehouse? Can that data warehouse be talking to another tool or services? Can I integrate that somehow? The data integration aspect is another important concept. But if you have a data store which is completely siloed and data integration tools are not solid enough to access the data, I don't think that tool will go a long way in your entire data strategy. So if you're looking for some of the important considerations to consider before you move to the strategy, the first thing is assess your landscape. The second one I would say is make sure that you have a sound strategy, like identify what you want to do with the data and who would be your consumers. And once you've done that, you identify the core services of your architecture that you will be using day in day out. That will be at the heart of your architecture. Things like S3 for storage, that will be the core piece of your technology. Things like your ingestion pipeline, MSK, that'll be, or Kafka, right, whatever you want to call it, that'll be your important technology. Things like data transformation and integration services, it can be Glue, it can be EMR, it can be any Spark tool that you can think of. Once you have that, then you have a solid strategy and you have a grip around what you want to do. And the final piece of the puzzle would be the governance. And governance is going to be a very, very important thing. Now, depending on whether you want a data mesh or a data fabric, the governance responsibilities will be distributed. And I'm saying this on a very high level. I'm not going very technical, but on a high level, data mesh, you are having a distributed governance with all the domain specific entities and teams handling the governance. While you move towards a data fabric, you're trying to integrate that and make it more centralized. But we are still making sure that the entire data access strategy is decentralized and the self-serve for the data is made available. So 4 pillars which I would like to call out when you want to, or 4 things you want to consider. It'll be strategy, assessing your landscape, core services, and your governance strategies.
So when you say strategic, like, do you even have a use case around it, right? Or just you've been hearing all
Exactly.
over
That's your
LinkedIn?
strategy. Correct.
Exactly. So it's not, hey, when you if you have a, if you're looking to think of moving towards this technology, the first thing or foremost thing you should be thinking of, like, even do I need this? Or my database or my data where is already
Exactly.
solving the problem.
Yeah,
Exactly. Yeah.
exactly.
I would even add a little bit more, right? Because I've been following data mesh and I've supported data mesh since it came out when I was still AWS. I think the biggest problem with these things is that they use technical terminology to describe a non-technical problem, right? So like data mesh in particular, when you say data mesh, I'm thinking data lake, I'm thinking data platform, I'm thinking technology. But a large portion of data mesh is not technology, it's organizational, right? It's how you structure your teams, how do you define, central versus distributed. There's a lot of organizational stuff. There is layers of technology where they're sort of saying like, here's a pattern for you to be able to technically enable these teams and provide services to them. But if you go through a lot of the writing on data mesh, it isn't fully thought through. Like it's here's a high level way of thinking about it, some conceptual boxes. But when it comes to implementation, there really isn't a solution, right? I remember when I was still working in Lake Formation, like we took the data mesh model and we say, how can we apply that inside of a tool? Like, because people came to us and say, I want to buy data mesh. I'm like, you can't buy data mesh. There's nothing to buy here, right? But we can help enable you to build a data mesh. And here's how we do it with Lake Formation and JPMC. I think talked at reInvent and a few other places about what they did with Lake Formation, cross account sharing, and that stuff. So it's important to understand sort of what is a recommendation and design pattern and what is an actual technology implementation that you can buy off the shelf and then use.
Exactly.
Data
Yeah.
fabric is a
For
different world.
main intention for this question was to draw a comparison, like,
Yeah.
hey, we had this trend around the data mesh. Now everyone wanted to build a data mesh. Now if you hear this trend around the data lake 2.0 or transactional data lake, lakehouse architecture, whatever you're going to call it,
Yeah.
it's just like you do not want to go into bandwagon, hey, we want to build this, we need this, because
Yeah.
we have been hearing cool stuff by Roy over LinkedIn, or by by Gagan over LinkedIn, or by me, right, or anyone else, right? Because Uh, so the first thing, definitely you need to have a case studies, or you need to have a real world case around it. So that kind of help to move me to my next segment is
But actually, sorry.
I
Before you move on, and I think Gagan wants to say something as well. Just quickly, I think if we're drawing a comparison between data mesh and data lake, or LakeHouse, my comment earlier about data mesh is not a technology, right? Where data lake house is a technology, right? So one is sort of saying data mesh is saying here's a design pattern to organize your company and your teams and how data should be shared across silos. Data lake house, data lake is not that, right? It's a technical solution to a problem. Like there's something you can go take off the shelf and go build, right? So it's important to kind of draw that distinction between them. So they're not the same thing.
yeah, means
Um,
more around the hype cycle. Was
okay, yeah,
my
makes
reference
sense.
was, hey, because
yeah.
that is like all of a sudden we had a like all the things was happening around the mesh and everything. So similar, like now we are happening around the data lake or data lake house. And like the whole intention of you getting your opinion was like, don't go into that bandwagon, and make your informed decision. And as Gagan has highlighted, four pillar,
Yeah,
right? The
absolutely.
first is use cases is super important. So move to
I,
our.
I think Gagan wanted to say
Yeah,
something.
one last thing, right?
I
Just to
cut
put
him
a
off
bow on
earlier.
top on that one, right? So I completely agree on what Roy mentioned. So these are tools. Lakehouse and Data Lake, they are tools, and data mesh, data fabric, they are paradigms. So they're not real thing. And final thing is, if you want to put data mesh, it is more of a domain-led data management, right? That's a very important thing. So each SME or each domain expertise will know how their portion of the data is to be managed. So that's again comes back to the original thing that Roy mentioned. It's a people thing. Sorry.
Got it. Yeah, now make.
Unfortunate naming.
Hey guys, this is not around the data mesh. I'm
Yeah,
so
yeah,
sorry.
yeah. No, no, no. But it's important to bring it up because people get influenced very easily by marketing and by
Yes.
advertisement. And once somebody starts sharing opinions and it just gets percolated, people are like, yeah, that's what it is. Like no, that's not what it is. Like you need to stop and think. Don't just take the heading that somebody.
Yeah, I mean that's
Used.
what, like, usually when we go, hey, we wanted to talk about what's the AWS offering around this technology. I was like, you really need this? I mean,
Right.
that's your question. Like, miss, this is so really nice. You wanna invest money? You can invest money around the Gen AI, right?
Oh, you want to throw money around the Gen A. I'm not sure
Let's
it's an
not
investment.
let's not talk about it
Yeah.
right now.
Okay, okay. I wanna sound cool by mentioning the Gen AI. Okay.
Yes.
Anyways, so let's move to our next segment. Emerging trend in this space, the data lake 2.0. So help me understand, Roy, because you've been do so much blogging or microblogging around this data lake 2.0 or iceberg. So help me understand how down the line around, like, maybe 2025 looks like in this space.
Yeah. So it's a good question. I think at this point, like where we are right now is very, very early days. Everybody recognizes this is including the big cloud vendors, the hyperscalers like AWS and Google, etc. The so-called data cloud vendors like Databricks and Snowflake, Salesforce, and also enterprises and small businesses are recognizing that vertical integration of data platform is nice, but there's a big tax, right? It's very expensive. And as we start collecting more and more data, it's much, much harder to store and use that data in different unique ways. And that's something that we need to find a better way to solve, right? Now, AI and being on a cutting edge and trying different tools, like you need access to the data in an easy way. And Lakehouse has kind of come up front and said, like, look, the data lake paradigm of putting stuff in object store is the way to do this, right? Performance is great. Storage scalability is unmatched, right? Cost keeps going down and will continue to go down, right? Accessibility. I mean, find me a tool who doesn't know how to read and write from S3, right? Pretty much anything nowadays does. So, that compatibility is there. So I think now when you look at, 2025, 2026, it's really about adoption. So today we're testing it, we're playing, we're getting some users to really put some pressure on it. The catalog race is starting to come up. I think the next race is going to be around data lake management or iceberg management, kind of what we're doing. There's going to be a conversation around the conflict manager. Like, how do you do multi-writer, multi-reader, multi-transaction? That's going to come, right? Because we're technically building a warehouse on top of an object store. So these questions are going to come, and there's going to be technology and innovation around that. But really what I think is happening what will happen in 2025 is we'll see much bigger workloads running on top of these Lakehouse formats, not just Iceberg, Delta and Hoodie and potentially Paimon as well. But we're going to see bigger workloads, more pressure testing. We'll work on a lot on performance. We'll work on scale. We'll work on integration, right? The whole idea of X tables and uniform, in my opinion, is a waste of time. Ultimately, all the query engines and other engines will just support the formats, just like we support JSON and CSV and Parquet. We don't need somebody to convert between JSON and CSV, do we? So there's no need for that. So I think it's really support, integration, those kind of things, and then performance and scale will be 2025. And then into 2026, you'll see a lot more around, multi-catalog, multi-transact table transactions, much better conflict resolution, improvement around streaming and things like that.
Perfect. And then maybe
No Gen AI though. Sorry, there's not going to be an iceberg function for Gen AI. God, I hope at least not.
I was about to say how the Gen AI, how Gen AI helped in the adoption of the transactional data lake.
I do have a comment on that. So, but I want to let guys.
If you don't have data, if you don't have data platform, there's no Gen AI.
Yeah.
Yeah, I think that's the very basic thing I've been seeing is missing around this proper strategy around the data. Hey, we have been data and we wanted to build the Gen AI, but why the things are not going into production the way we wanted to go into production is this very fundamental problem is not have a proper strategy around the data and what's your data mean, what the data is all about. So you wanted to have a quick comment, Roy, sorry.
Yeah. So there are two parts to Gen AI, LLM, RAGs, all that kind of stuff. There is one aspect where Iceberg Lakehouse formats is basically saying, here's the data, easily accessible, managed, and governed. Anybody can access it, right? Whether it's from an LLM tool or from Spark or for whatever. So it's kind of basically unifying access or making it ubiquitous to all these tools. That's a critical component of getting data into more and more of these tools so you can do more things. The other aspect of it, more specifically to the table format and the technology behind it, is where I'm starting to see, and it's not necessarily Gen AI, more like LLMs and some RAG and some other things, is how do we make the kind of the data management aspect even easier? So like, as you both know today, like when you go create a table, you got to define your partition keys. You got to define your sort order. You got to define all the primary keys. You got to define all these things that today make sense. But in 6 months from now, your query patterns are going to change. Your data pattern is going to change. You're going to have to rebuild the table because your partitions are going to be different. Or you want to partition differently, right, to get better performance. And this is constant. It keeps going. It keeps moving. So where I see kind of like, for lack of a better term, like Gen AI technology or just AI technology improving or helping this format is allowing us to be more intelligent about how do we design the table layout or the data layout on S3. Can we automatically learn from query patterns, from data patterns, and say like, yes, you chose column X to be your partition column, but nobody's querying on that, nobody's filtering on that column, so it doesn't make sense. But I see in your data that you have this other column that's actually much better. So I'm going to repartition your table to adhere to that. One thing we're doing, and this is not LLM specific, but we've built technology in Absolver where we call it dynamic partition promotion. What it does is it basically looks at your data, at all your columns, and say, let's say you partitioned on country. but all of your customers today are US customers. So your US partition is going to be full of data. Now you launch into, I don't know, Portugal, right? You don't have a lot of data there. So you're creating a Portugal partition, but there's nothing in it. There's no data in it. It's very, very little. So you don't get the performance benefits, and you start creating all these tiny partitions. So what we do with us is, look, we look at the data and we say, look, the data is skewed. Portugal data is very, very little. So we're not going to actually partition. We're not going to create a physical partition. We're going to cluster. So we'll create a file and we'll add data into it in a cluster, basically into that one file that's sorted and organized on that column. So you still get query performance, but there's no physical partition. When we get to a point where there's a lot of data or enough data in there, we'll split it up into a physical partition. So this is something we don't use LLM or AI today for that. This is our internal kind of algorithm. Yeah. But I really see LLMs and these AI technologies coming and helping more and more with this type of stuff, because the optimizations behind the scenes today is very physical. Data engineers have to constantly stay on top of it and constantly change it. I think in 2026 or 2025 towards 26, we're going to see more of that happening. And Databricks has a little bit with liquid clustering and intelligent optimizations. Obsolver has the adaptive optimizer that does this. I think you're going to see more and more of that coming up.
Makes sense.
Sorry, long rant.
Our initially was intended more around how we are having this data being stored for the embedding and for vector. Yeah. This way, Gen AI application directly able to talk to your data lake. Anyways, so let's move to our next segment. That's where we're looking to talk around case studies and real world use cases. Gagan, I know you have been instrumental on helping customer to to adopt this technology. Without naming any customer, can you help me to understand any real world use case which you have worked upon? Was the case so if someone is watching this this podcast, they able to relate, hey, this is my use case as well, and this is how I have solved. So do you have any use case to share? And then Roy, I will come to you on the same topic.
Sure. So I'd just like to call out, right, without naming the customer, this use case, or more specifically with the enterprise support platform, where you are opening up support requests. They have multiple customers, like me as an entity. I would want to buy the support platform so that I can see how my customers are doing. And as you can imagine, every conversation you have in a support platform, you will have an update. You will have a new conversation added. And every time you have that, you will have to just go ahead and update a particular case, for example. And this was one of the challenging situations where a single message would create tiny, tiny files. So ultimately, what the customer was ending up doing was, we was having a rare scenario where customers paying a lot more on the API calls, the list calls and put calls, and get calls, rather than the storage costs. And that's how hard the situation was becoming for the customer. And that is where some of these OTFs, modern table formats, or OTFs, you want to call it, they came in handy, and they allowed to alleviate that pain to an extent that they reduced their almost entire list calls on S3, and they are significantly improved the performance for their downstream applications. So previously, at their data freshness guarantees downstream application was approximately an hour. They had cut it down to approximately 5 minutes. They were having the updates made to the entire case history for all the customers combined within five minutes, which was a significant improvement. And that is one of the examples that I can give. And this was implemented on Hudi. And then I have similar examples where customers have successfully implemented things.
I will pause you. So sorry, but let me understand. So if I try to envision this current architecture, the previous architecture, so they had this customer executive. They used to chat. They used to stream the data, and that streaming used to go into S3, but it used to create a lot of small files.
Correct. Sorry.
I mean to say,
I'll come back. Yeah. So when I say support ticket, it was not chat was one of them, right? But also offline support, where you have email support tickets.
Okay.
Where you send a communication, and every communication from the agent, from the customer, the end customer, will create a new file or a new conversation record. And that record would be a small JSON file, which is hardly a few kilobytes, sitting on S3, which will have a pointer to an actual support ticket, the tenant ID, which in this case would be an organization who bought support from this particular customer.
Got it. Okay, makes sense. It's more like the multi-tenancy where they manage the
Correct.
discussion. They manage all the communication with the customer for you.
Yes.
Okay, that makes sense now. Right, over to you.
Sorry, am I muted? No, I'm not muted. Sorry. Trying to watch two different things. Trying to watch us on YouTube. But it's all good. It's all good. So there's many different use cases. I love the example that Gagan shared. It's a definitely good one. I think it's a good scale slash cost use case. Another cost use case that I've seen, and this is in particular to data warehousing, as we talked about in the past. We have a large company or enterprise that we work with, one of our customers. Today, they're using Absolver to load data into their data warehouse, into Snowflake. They have about 25 different lines of business that are producing data and sending it via Kafka into Absolver, and then Absolver then split it up, creates tables, and then writes it into Snowflake. They're all in on Snowflake. They love the query engine, but over the last couple of years, they're starting to collect a lot of data, and what they realize is that the raw storage is really adding up, and they want to be able to move that into the LakeHouse. Still maintain kind of the gold tables and the analytics tables in Snowflake, but they want to move the raw data into the lake. So what they're doing is with Absolver is simply saying, okay, let's write everything into Iceberg tables inside of the lake. Absolver manages and optimizes that data. Expose those tables in Snowflake as the bronze or the raw tables, and then continue using DBT and all the transformation processes that they have to model and transform and create the silver and gold tables for them inside of Snowflake. So by doing that, they removed a lot of the raw data storage and a lot of the early transformation or compute requirements of cleaning the data, modeling it and sort of like optimizing it before they get into like the business logic type of transformations. And that, we're still in the process of migrating that, but they expect that's going to save them a lot of money. It's going to save them several thousands per month, which is a big deal. So I think that's one use case.
So now I think we are moving to our last segment, right? The road ahead. So one question I have in mind is we are hearing all the great stuff about this data lake 2.0 or transaction data lake. Do we really need a data warehouse before we can talk around the road ahead part? So do you think, like, do we need a data warehouse or is gonna get extinct?
Gagan, go ahead.
I would say we still need a data warehouse. It's not going to go anywhere. It'll be there, but it will work with a solid data platform. And when I say it'll be used as a data mart, because you still have reporting requirements where you need to have BI queries running against a data set. Yes, there has been innovation. I'm surprised with the performance of some of the compute engines on an iceberg table format. It blows my mind when you look at the compared performance, 5 years back, 2 years back to today. Something like Trino, it's super fast, for example, today in some of the use cases. But it may be some still low latency reporting use cases where you will still need a data warehouse, but not to that extent. You can cut down your data warehouse footprint and only use it as a data mart. Right.
So yes and no, and I love what Gagan said, and I agree 100%. The yes is yes to everything Gagan said. The no is, I think it's a phase. I think as for lack of a better term, the old guard is transitioning out of the industry. The folks that grew up on data warehouses, love data warehouses, know how to operate and optimize these data warehouses, is that old guard starts to shift out of the industry and the new guard is coming in. I think we're going to start seeing less and less dependence on the warehouse and more flexibility and openness to go try something else. You said it again, Trino, right? There's Starrocks, there's ClickHouse. There's so many options on the market today.
Starburst.
Starburst, they all speak SQL. They all work very similar to a warehouse. But I think a lot of the users who are invested in warehouses, it's what they know. It's what they know for many years. They're comfortable with it. it's just it's familiar, right? So once that sort of shifts out of the industry, I think the new folks coming in, and I'm seeing this, of course, on LinkedIn and the training that I do, and you see this in lots of places as well. People are familiar with SQL, but they're also familiar with Rust and Python, and they have no problem spinning up a Docker container and running some code, right? So people are more familiar, and Gen AI will generate some SQL for us and some Python for us. God, God help us.
Um,
But I think ultimately that's going to shift. So no, now warehouses are going to stick around. They're going to have more support for Iceberg and these lake formats. But in the future, they basically become, these glorified query engines with a lot of capabilities. But at the end of the day, they're not going to be that much different in concept to Trino or Spark or these other tools. It's
so
just
do
going to
you
be very well integrated.
So, do you think in a near future, and then I can go to Gagan first and then come to you, Roy. Do you think in near future is a possibility around not to have the data duplication across multiple vendors, but having one unified data, whether it's sitting on AWS, whether it's sitting on Azure, whether it's sitting on GCP, and based on choice of the engine I wanted to work on, whether it's a Redshift,
Yeah.
Glue, Athena, Presto, Starburst, Absolver, or any Snowflake. I don't want to name everyone, so
Right,
everyone.
right, right. So I mean, honestly, that's our vision. Like if you see some of my presentations, my webinar, I call this shared storage, right? Basically saying that whether Absolver is loading the data or Glue or Spark or whatever, data is in your object store within your cloud, let's say AWS, accessible through Glue Catalog, Polaris, whatever that may be. But I don't care what catalog you're going to use; it's the same data, right? The physical files don't change, right? You just have a different tool pointing to it, and you can query that. Now, can that be a single point of a single source of truth across clouds? I think that's a technology and a cost question. It definitely is possible because BigQuery has support for Iceberg. Azure, not yet, but I'm sure they will. IBM does. Salesforce does. So there's really no reason why you need multiple copies, besides the fact that these are sitting on two physical networks. If I'm on AWS and I got to move a petabyte of data to Google to get good performance, I'm going to pay, right? And then you're not going to be able to move back and forth, back and forth. So there's some new tech and new design patterns around this, like the Snowflake data sharing is really interesting, and how they sort of warm up your data in your target cloud. So if the data is in AWS and you want to query it in Google, they sort of warm it up, right? They give you the first set of rows in Google so you can get query, and then as you query, it starts to kind of like incrementally load the data. Um, it's not rocket science. We can do this, but the need isn't 100% there, but it's going to start coming. So I think we're heading in the right direction. We're not technically there yet, but heading in the right direction.
Gagan, your take here.
I would say plus one to everything Roy mentioned, right? It's going to be there are some certain challenges that I see, especially the distributed nature of the data that we have in different clouds or different hyperscalers. The way that you can solve this is either using something like Roy mentioned, like warming up, which Snowflake does, or have some sort of a inter cloud communication where you can push down some of your query patterns without really pulling in on the data. Just do the push down to a native query engine within the cloud, have the aggregated or results streamed across from whatever cloud you're
Yeah,
querying.
BigQuery
But
kind of does this today.
yes,
It's not
yep,
super efficient, but it's there.
yes.
Yeah.
But the biggest piece of the puzzle would be lying with the catalogs and all the rest catalogs that we see today. The open source Nesses, the upcoming Polaris, the Unity catalog, that they will hold the key for a lot of these integrations, and that is where the next war would really be heating up, and that's going to be
That,
the
that,
catalog
that's,
war.
that's things getting interest. That market is definitely getting interested, especially
Yep.
after making Unity catalog as an open source now to compete with the Polaris. So it's gonna be super fun to see how this turned out, and we are hoping for the best. So with that, I think we'll end up our podcast here. If any of you are watching, do post your comments, like, share, subscribe, and do I miss anything to say? No, right?
Yeah.
Smash that subscribe button, as they
Yeah,
say on YouTube.
subscribe to Navnit Shukla.
Subscribe. No, not this. Like
No, not this.
yeah, subscribe this button here
Yeah.
below. So thanks
Awesome.
again. Thanks for joining this podcast. It was such a pleasure talking to you guys, and looking forward to have you much more discussions in the future. Take
Of
care.
course, I'm happy you're doing this. Congratulations on the start of this series, and hopefully you keep going. So anywhere we can support you, I'm here for you, my friend. Thank you for the time.
Yep.
Thanks.
Gagan, you too.
Same here. And thank you so much for having me. And as always, you can call me out whenever you want to hear me talk. Yep. I love talking. So
Perfect.
I'll be
Thank you.
here.
Thank you.